Hello, class 12 ML Aggarwal students. Welcome once again to Math is Possible. Today I am going to continue your video for continuity and differentiability. And I have done till question number 4. I am going to start with question number 5. I have already written the exercise number and what we have to do. I have already written. Okay, you have to examine for continuity. Okay, this was the heading. Now we are going on to question number 5. Question number 5 is given as f of x is equal to 3x plus 5. That happens when x is greater than or equal to 2, and it is x square if x is less than 2. And you have to check for continuity. You have to check the function is continuous at x equal to 2 or not. You have to check whether the function is continuous at x equal to 2. So start, you know what to do. You have to start with RHL or LHL, whatever you feel like doing. So limit of x tends to 2 positive, approaching from the positive side, f of x is equal to limit of x tends to 2 positive. Look, it's approaching from the positive side. What does that mean? If you draw the graph, okay, if you draw the graph, is approaching, say this is 1, okay, this is 2, okay, the graph is approaching 2 from the positive side, okay, suppose this is the graph, it's approaching 2 from the positive side. So if it's approaching 2 from the positive side, that means it was coming from the side that is greater than 2. So greater than 2 means you have to use this functions. Look over here, these points, the values over here will be greater than 2, say 3, 4, whatever it is. Okay, so which function we will use? We will use the above function when x is greater than or equal to 2. So greater than 2, that is 3x plus 5. Put the 2 over here. 3 2s are 6 plus 5. That is how much? So 5 plus 5, 10. That is 11. Okay. Now let's start with the LHL, left hand limit. So limit x tends to 2 negative, f of x is equal to limit x tends to 2 negative. Which one you are going to use now? You are going to use x square. Why are we going to use x square now? Why are we going to use this x square? Now look, now it's approaching 2 from the negative side. It's approaching 2 from the negative side. So the graph is coming this way. Okay, so if it's coming from the negative side, then obviously less than 2, then we will use x square. So this is what this is coming as 4. So you can see that the RHL and the LHL are not equal to each other. So you write, so limit x tends to 2 negative, f of x is not equal to limit x tends to 2 positive, f of x. Hence what happens? Hence f is not continuous. Hence f is not continuous. Whatever, f is not continuous. So let's check this answer. 5.1, where is the answers? So it's a very long chapter actually. 5.1, yeah, I got it. 5.1, question number 5. It says no. That means it's not continuous. Okay, so question number 5, it's not continuous. Let's go on to the next question, that is question number 6. Okay. Let me tell you students, these are all easy questions. Okay, these exercises, the first exercises, just to understand. You have to understand the concept and then later on apply it to difficult questions. Okay, let's go on to question number 6. This is the function that is given. F of x is equal to 2x square minus 3x minus 2 whole thing divided by x minus 2. and down over here it's 5, it's given, and this part will be used when x is not equal to 2, when x is not equal to 2, okay, and it will come 5 when x is equal to 2. And of course you have to check whether the function is continuous at x equal to 2. At x equal to 2. So we are going to check the function whether it is continuous at x equal to 2. All of you know what to do. Start with RHL, start with LHL, whatever you feel like. Let's start with LHL now. In the previous question I had started with RHL. Okay, so the left hand limit. What is the left hand limit? Let's start left hand limit. So limit x tends to 2 negative, okay, f of x, 2 negative f of x. That means if you concentrate, now you must be wondering which function to take. Okay, 2 negative means approaching 2 from the negative side. Approaching 2 from the negative side. That means, that does not mean it's already gone to 2. Okay, it's approaching 2 from the negative side. That means it's not equal to 2. So it's approaching 2 does not mean it's equal to 2. Okay, you are approaching, my hand is approaching the board does not mean that it's touching the board. Okay, so it's approaching 2 does not mean it's equal to 2. So if it's not equal to 2, then we have to use this function. Okay, so limit x tends to 2 negative, okay, you have to write 2x square minus 3x minus 2 whole thing divided by x minus 2. Now if you notice, if you put 2 over here and 2 over here, this is not happening, it's coming undefined, because then the denominator is becoming 0. So that's not possible. That means what you have to do, you have to do midterm break over here. So do it. 2 2s are 4, you are in class 12, 2 2s are 4, 4 minus 1 will give you 3. So you don't have to do it in the rough, you can already, you can just think and do. So 2x square minus 4x, okay, plus x minus 2 whole thing divided by x minus 2. Okay, now from here, next step is limit x tends to 2 negative, that is 2x common from here, markers are not writing, x minus 2 plus 1 common from here, and x minus 2 whole thing divided by x minus 2. Alright, from here, very simple, don't write equal to because that's not allowed. Okay, you have to write one more step. Okay, you have to keep writing the limit. So from here, now next step will be equal to limit x tends to 2 negative, okay, x minus 2 bracket 2x plus 1 whole thing divided by x minus 2. I know you can, hope you can see it. X minus 2. So this x minus 2 and the x minus 2 got cancelled out. So finally we are left with what? Limit x tends to 2 negative. Okay. Now you can put the value. Actually you don't have to write one more step. Put the value. Don't need to write one more step. Just put the value of 2 over here. So that's 2 2s are 4 plus 1. Answer is 5. So what happens? Limit x tends to 2 negative, f of x is equal to 5. Alright. Limit x tends to 2 negative, f of x is equal to 5. Now let's go on to the next one. That is the RHL. Okay. So LHL is 5. Okay. You can write, I'm writing it over here. LHL is equal to 5. Left hand limit came 5. Now RHL, what do you have to do? Limit x tends to 2 positive, f of x, limit x tends to 2 positive, f of x is equal to limit x tends to 2 positive. Which one will we use? Now look, 2 positive means approaching from the right hand side. Okay, 2 positive means the graph is approaching 2, say, from the right hand side. That means it's not equal to 2, it's greater than 2. So we don't have greater or lesser rules over here. We just have equal to 2 or not equal to 2. So it's not equal to 2. So we'll use the same thing. Now you don't have to write the whole thing again, expand and again cancel and all. You just write what? You will write 2x plus 1 because that becomes 2x plus 1 which is equal to 5. See, RHL is also 5 when you put 2 over here. Now you have to find the function. So f of 2 means what? When x is equal to 2. So when x is equal to 2, the answer they are telling you to take as 5. So you will write LHL equal to RHL is equal to f of 2 which is equal to 5. So yes, this is continuous. Don't write like me in short. You have to write properly. You have to write limit of x tends to 2 negative equal to limit of x tends to 2 positive. F of x is equal to f of 2 is equal to 5. Hence the function is continuous. You have to write properly. Okay, don't write like me because my marker is finishing. So that's the reason why I'm writing in short. Let's go on to question number 7. So this function is continuous. Let me check the answer for you. Okay. The function is continuous. 5 part 1 question number 6. It's written as yes. Yes means the function is continuous. Okay. Yes, no, they have written the answer. It's no problem. It's okay. Question number 7. This is what question number 7 is. Question number 7 says f of x is given as x divided by sine 2x. F of x is equal to x divided by sine 2x when x is equal to 0, not equal to 0, x is not equal to 0, and it will become 2 when x is equal to 0. And you have to check, obviously you have to check whether the function is continuous at x equal to 0. So let's start checking whether the function is continuous at x equal to 0 or not. So start with your LHL or RHL. Starting with RHL now. RHL, so limit, okay, x tends to 0 positive f of x is equal to limit, oh god, why didn't I get one? X tends to 0 positive. So positive 0, that means approaching 0 from the positive side. That means not equal to 0. So when it's not equal to 0, what do you have to take? You have to take x by sine 2x. Okay. Now, those of you who are thinking that now what to do? What are you going to do? Are you going to put 0 here and 0 there? Not possible. You see, there is a rule. There is a limit formula. Those of you who know it already, that is limit of x tends to 0 sine x divided by x is equal to 1. In class 11, we learned this. Okay, limit of x tends to 0 sine x by x is equal to 1. So which implies if you write limit of x tends to 0 sine 2x, if you write, then you have to divide by 2x and still the answer will come 1. Now look at this. What do we have over here? We have 2x over here. So we need to divide by a 2x. We need to divide by a 2x. So let's divide by 2x. If we divide by 2x here, we need to divide by 2x there also. So start doing limit of x tends to 0 positive. Okay. X divided by 2x on top. Okay. X divided by 2x on top. And sine 2x divided by 2x. Now let's see if we are getting back the question or not. Let's find out if we are getting back the question or not. So let's see. The x and the x cancels over here. See, the x and the x cancels over here. The 2 and the 2 cancels over here. Okay, and this x goes up. If you are not understanding this, then I'll have to split and write. Look, if you write this in the rough, if you write this in the rough work column, you get x by 2x divided by sine 2x divided by 2x, right? Look at, this is what you are getting in the rough. Okay, now when you solve it, you must check whether you're getting back the question or not. So there's a 2x there, here sine 2x. No, you cannot see, sorry about it. Sine 2x. Okay, now see, the x gone, 2x gone from here, whole thing, and x by sine 2x. Aren't you getting x by sine 2x? So that was the question, x by sine 2x. Now basically my question is over. Okay, what I have to do? Simple. Over here I just cancel out the x and x and bring the 1 by 2 in front. Bring the 1 by 2 in front. Why? Because that's a constant. Okay, it comes out, and then I split the limit. How do I split the limit? On top I don't have to write any limit because on top is just 1. Okay, x and x got cancelled out, 1 by 2 came out. And over here I will write limit x tends to 0 plus, okay, sine 2x divided by 2x. See, this is divided. Okay, 1 divided by limit. So what happens is, there is also a rule that if you have limit of x tends to 0, f of x divided by g of x, if you have, then the limit of x tends to 0, f of x divided by limit of, you can also write this as limit x tends to 0, f of x on top, and limit x tends to 0, g of x down. That means the limit is distributed. Okay, limit is gone to the denominator also, limit is gone to the, limit is gone to the numerator also, limit is gone to the denominator also. Same way over here, the limit is, this limit is distributed to the numerator and the denominator. Since the numerator is 1, so I didn't write anything, but the denominator is not 1, it's sine 2x by 2x. So over here the limit I have written. So what is limit of x tends to 0, sine 2x by 2x? It's equal to 1. If you had sine 3x, then you will divide by 3x. If you have sine 5x, you will divide by 5x. Remember that. If you have sine theta x or sine whatever x, you will divide by that same value. Okay, so over here it's 1 by 1, so answer is half. Okay, so eventually what your answer came as? Half. So limit of x tends to 0 positive, f of x is equal to half. Now let's go on to the second part. Let's go on to the LHL. Okay, now let's go on to the LHL. So RHL came as half. Write it somewhere. Oh, you don't have to write it because you are doing the whole thing. I am writing it somewhere over there. RHL came as half. Let's start with LHL, left hand limit. Okay, so limit x tends to 0 negative, limit of x tends to 0 negative, f of x is equal to, limit of x tends to 0 negative, f of x is equal to limit of x tends to 0 negative, again you will take the same, x divided by sine 2x, right? So the answer will come what? 1 by 2. Why x negative? Why will you take this one? Why? Simple. Because you will have to, you see, this is approaching from the negative side. Simple logic. This is approaching from the negative side. So if it's approaching from the negative side, so it's not equal to 2 and it's not equal to 0, and if it's not equal to 0, then you will take the top function. Simple logic. And in RHL you did the same thing and you got half. So over here you don't have to do the same thing, you just write half. Okay, and whatever you had done, it's over here. Okay, it's over there. So half. Now f of 0. What is f of 0? 2. So can you say that the function is continuous? No, the function is not continuous. No. Why it's not continuous? Because LHL is equal to RHL, but it's not equal to f of 0. That means the right hand limit and the left hand limit are equal to each other, but it's not equal to the function. Okay, hence the function is not continuous at x equal to 0. So the answer of 7 is no. So you can see that the function is not continuous. Simple, because it is the right hand limit and the left hand limit are okay. The right hand limit and the left hand limit are okay, but it is not equal to the function. And there is a theorem that actually I had written for you, where the right hand limit and the left hand limit will be equal to each other, but will not be equal to the function. So I cannot find it over here as of now, but I have written it for you. Okay. Anyways, no problem. That's not what you have to know as of now. So the left hand limit and the right hand limit are equal to each other, but it's not equal to the function. Hence, the function is discontinuous. So what was the actual rule? The rule was that the left hand limit has to be equal to the right hand limit, and that has to be equal to the function f of x. So all these three, when they are equal to each other, okay, then only the function is continuous. Otherwise the function is not continuous. So here you can see it's not continuous. If you get the LHL and the RHL are not equal to each other, okay, then the first part only it's not continuous. Then you don't have to check for the function. Okay, so this is question number 7. That's done. Let's do one more question, that is question number 8, and finish off today's this part of continuity. Okay. So let's do question number 8 now. So this is what question number 8 is given. Nothing is being written. This is what question number 8 is given as. It's given as f of x is equal to kx square. F of x is equal to kx square when x is less than equal to 2. X is less than equal to 2, and it is going to be 3 when x is greater than 2. Okay, now it says that find the value of k so that the function may be continuous at x equal to 2. So it says the function is continuous. F is continuous. 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 Whatever it is, forget the spelling, focus on the mathematics. It's continuous at x equal to 2. The condition is given, the function is already continuous at x equal to 2. So if it is already continuous at x equal to 2, that means LHL is equal to RHL is equal to f of 2. Okay, so it's already, this condition is already satisfied. Alright, now all we need to do is just find the LHL and find the RHL. So let's start with the LHL. LHL, so that is limit of x tends to 2 negative f of x is equal to limit of x tends to 2 negative, so less than 2, look at that, less than 2, and write kx square, which is actually, when you put 2 over here, so it becomes 4k. See, put 2 in place of x and square it, so that's 2 square, and k was left, so that is kx square. Now RHL, right hand limit, that is limit x tends to 2 positive f of x is equal to limit x tends to 2 positive, that means greater than 2. Okay, so what will be the answer when it's greater than 2? You can easily see over there, it's written over there 3, so eventually this becomes 3. So finished. LHL and RHL are equal. F of 2 you don't need to find, there is no use, since we already got LHL equal to RHL. Because the function is continuous, you can use only this part, LHL equal to RHL. Okay, these two things are equal to each other, LHL equal to RHL, so write it. So what will you write? So, or since the function is continuous, so LHL equal to RHL. Since you will write the whole thing, since the function is continuous, so limit of x tends to 2 negative f of x. Don't write LHL, write limit of x tends to 2 negative f of x equal to limit of x tends to 2 plus f of x, or positive f of x. So what is the LHL? This is 4k and this is 3, hence k is equal to 3 by 4. So that's your answer for question number 8. Let me just check it out. Question number 8, 3 by 4. Correct answer. That's it for today. We will continue this chapter in the next videos. Okay, there are many more questions over here and many more questions are yet to come. So keep taking as much help as possible from my channel and your channel, Math is Possible. See you in the next video. Bye bye.